Hello, Honors Algebra 2 students. Welcome to 7.5 Day 2. Hopefully you've downloaded the notes. If not, then you can just take the notes as we go. Ta-da! All right, I need to adjust this a little bit. Okay, as you recall, this is just a review, the product property. I'm going to bring this up a little bit. There we go. There's going to be some glitches in the gears here, guys, so bear with me. If you recall the product property, let's say, my dog is trying to get in her food, sorry. Let's say we have the log base b of m times n. That is going to be equal to, if you remember, we separate that as a log base b of m plus the log base b of n. Now I'm trying to use a bolder pen, but I think that might cause a problem for us. So there you go, that's what that would look like. Log base b of m plus log base b of n. Now I'm changing my pen. Now if you remember the log of the quotient, so we would have a log base b of m divided by n, which would be equal to the log base b of m, which is the numerator, so it's positive, minus what's in the denominator, log base b of n. The power property, log base b of m to the n, if you recall, the n comes down in front, n log base b of m. So that's just a review of the properties. Now what I wanted to show you, and I forgot to show you in the other problem, let's say we want to expand and we have a log base 2 of, let's say, the fourth root of 3. So what this would end up being is the log base 2 of 3 to the 1/4. Change that. Change this right here so that it is a fraction. Now the 1/4 comes down in front, log base 2 of 3. Now if you're having problems with that in the homework that you had before, you might want to go back and work on that. Okay, so when we're condensing, I'm going to move this over here. When we are condensing a logarithmic expression, the very first thing we have to do is use the rules to go backwards. I'm just going to rewrite that as use the rules to go backwards. What we did previously is we expanded, we got this. So what we're doing now is we're trying to figure out what is the way of showing this before we expanded it. So this is condensing. Okay, so what we will do now is we will take, this is the log of 6 plus, now I'm going to take this 2 and I'm going to put it up there. The log of 2 squared minus the log of 3. These two will be in the numerator because they're both positive. So this is going to be 6 times 2 squared. we could put 4 there. This is minus, so this goes in the denominator, divided by 3. Now I want you to notice, be very careful, don't make that line go beyond here because it's the log of this whole thing, not the log of 6 times 4 divided by the log of 3. That would give us a totally wrong answer. This is then going to reduce. So 6 times 4 is 24 divided by 3. It's just going to be the log of 8. And there it is, simplified. Condensed and simplified. Let's look at example 2. This is the natural log of 16 minus the natural log of 4. So we're going to write this as the natural log. That's out in front. And it's going to be 16 is positive. That'll be in the numerator. And the minus the natural log of 4 puts that 4 in the denominator. Simplified, we have the natural log of 4. And that's our final answer. Give you a second there in case you're still copying. Okay, now let's move on to example 3. I might zoom in on that a little bit more so we can see it a little bit better. Move some of my stuff out of the way. Okay. First thing that we're going to do is we're going to take this and put it up on as the exponent. So this becomes a log base 16 of 12 to the 4th. And this is log base 16. So let's go ahead and put that 4 up there again, minus the log base 16. That's my dog drinking her water. 2 to the 4th. Thank you, Maisie. That then becomes a log base 16 of 12 to the 4th divided by 2 to the 4th. Notice how that is just got the line here, not back here. It's a log base 16 of this whole thing. That, if you do 12 times 12 times 12 times 12 divided by 2 times 2 times 2 times 2, you're going to just end up with a log base 16 of 1296. So if you recall, if we wanted to find the answer to that, we could. We would find out 16 raised to what power would give us 1296. And I'm going to show you a way to do that in a little bit. Now, at this point in time, I would say any questions, but I can't do that because you're not going to be able to answer that. Okay, let's move on to the next problem. Okay. What I'm going to do first is bring the 7 up on top and make that log base 4 of 2 to the 7th power. I'm going to bring the 5 up for this one. This will be log base 4 of x to the 5th. And I'm going to bring the 3 up here. This will be log base 4 of y cubed. Now we couldn't condense this if they all didn't have the same base of 4, but you can see that there's a 4 here, a 4 here, and a 4 here. These are all positive. There's an assumed positive in front of the log base 4 of 2 to the 7th, and the rest are positive, which means when we condense this, we write the log base 4 of 1, log base 4 once. Then we're going to have 2 to the 7th times x to the 5th times y to the 3rd. What we could do is we could do 2 to the 7th power. 2 to the 7th power is 128. Log base 4 of 128, x to the 5th, y cubed, and that's done. Give you a second to look that over, copy it down. You can always pause the video and rewind and go back if you're having problems. Okay, moving on. Trying to get it so you can see it more clearly. This is a trial and error, guys. Doing the best that I can with what I've got to work with. All right, this one, we can't, there's nothing in front to do that, so we're just going to leave that as log base 3 of 2. We're going to put the 1/2 at the top. Log base 3 of y to the 1/2. So now this becomes, since they both have log base 3, we're going to write that once, and they're both positive, so this is going to be a product, 2y to the 1/2. There's our answer. You could write this as log base 3 of 2 square root of y, because y to the 1/2 is the square root of y. Moving on. Example number 6. This one looks a little more complicated. So what we're going to do is we are going to distribute that 3 through first. So I'm going to end up with 3 times the natural log of 3 minus 3 times the natural log of x. I'm going to distribute this through. This will be minus the natural log of x. There's no exponents to worry about here. Minus the natural log. Oops, that's not minus, it's plus. Natural log of 9. I know a lot of you are probably thinking, wait, that's plus. We got it fixed. Now what I'm going to do is I'm going to bring these coefficients that are in front here, and I'm going to bring them up as exponents. So this is going to become the natural log of 3 cubed minus the natural log of x cubed minus the natural log of x plus the natural log of 9. Oops, sorry about that. Sorry about that. Okay, now they're all natural logs. So we can write the natural log once. And all of the pluses go in the numerator. So this term is positive, so this is 3 cubed. And I'm going to call that 27. I think you guys realize that 3 cubed is 27. So I'm just simplifying that. And this is also plus here. So I'm going to be multiplying that by 9. The 2 that are minus go in the denominator. So that's going to be x cubed times x. Since they are both negative, they go in the denominator. And when we simplify that, that's going to be the natural log of 243 divided by x to the 4th. Now, I cannot stress this enough that if you were to write it this way, let's say if you were to write it this way, the natural log of 243 divided by the natural log of x to the 4th. They are not the same thing. Do not do that. You write the base, you write the natural log or whatever it is, log base, whatever, once, and then you put the numerator and the denominator separate. This does not come over the top of that either. Be careful. Because what we're saying is we want the natural log of this quantity the way it's written. Not the natural log of 243 divided by x to the 4th. The natural log of the whole thing, 243 divided by x to the 4th. Give you a couple seconds to get that written down. And remember, this is not true. That's why I crossed it off. Okay. Ruh-roh, look at what happened when I did that. It bled through. Okay, we'll just write up above it. Change of base formula. Now, some of your fancy calculators can do the different bases, but your regular graphing calculator will not. So if we want to calculate a certain value that doesn't have a nice easy base and it doesn't come out nicely, we have to find a way to do that. And the way we do that is using the change of base formula. So what we would write is, if we were looking for the log base c of some number a, the formula will be log of a divided by the log of c. Now this is where it changes. From what I told you before, we actually have the log in the numerator and the log in the denominator using the change of base formula. This is also true with any of the bases. We can do the natural log base. I'm sorry, I apologize there. I had to pause for a second. This is going to work out the same if we do the natural log of a divided by the natural log of c. If you were to go ahead and try this with a calculator, you would see that this is true. And we will be looking at a few and we'll see that that actually works out. So whether you use log or you use natural log on your calculator is totally up to you. So let's go with the first problem that we have here. I want to find out, basically what I'm saying is 3 raised to what power is 7? So this is the value I'm trying to find. Now it's a little bit difficult. That doesn't come out nicely. So what we would have to do is use a change of base formula. We're going to rewrite this as log of 7 divided by log of 3. Now when you go to do this on your calculator, you need to make sure that you use the parentheses correctly. So what I'm saying is, when you go to push log on your calculator, you will get a set of parentheses. And you're going to put 7 and end that parenthesis before you do the division and then do log of 3 on your calculator. Make sure that you end this parenthesis before you do this. And we're going to do this out 3 decimal places. So remember, we're going to use a squiggle because it's not exact. So if you push this into your calculator, what you should get is 1.771. So go ahead and push log 7, end your parentheses, divide by log 3, and hit enter. Now I want you to notice that if you go ahead and do the natural log of 7 divided by the natural log of 3, you're going to get the same answer. The exact same answer. So it doesn't really matter if you use log or if you use natural log. Okay. We're going to go over to number 8 now. Now, if you want to, you can turn the video off and you can try the rest on your own. Then turn the video back on and see if you got them right. So that's totally up to you. We would take the log of 12. Now, if you notice, this is the way I remember it. This is the bigger number when you're doing this out. See, the base is a smaller number, so since the 12 is bigger, it seems as if it's more important. So that should be in the numerator. And the log of 7, I'm sorry. Remember to end the parentheses for the 12. That's going to be approximately equal to 1.2 7, 7. Now what I want you to notice is if you were to check this, if you were to take 7 and raise it to the 1.277, you would get an answer that is extremely close to 12. And the reason why you don't get exactly 12 is because we've rounded. If we had the exact value, it would be 12, but we did some rounding. Okay, moving on. Log base 9 of 25. 9 raised to what power is 25? So you go ahead and plug in your calculator, log 25, the whole thing, divided by the log of 9. Don't forget the entre parentheses. I probably have said that way too many times, but sometimes it takes that many times to remember. 1.465. Okay, number 10. 6 raised to what power is 9? Log of 9 divided by log of 6. And again, you can use natural log. I get approximately 1.226. 1.226. I think you've probably caught on by now, so I'm just going to give you the answers to the last two. The answer to number 11 is approximately 2.153. And the answer, 2.153. And then the answer to number 12 is approximately 1.774. If you have any questions on this, please email me. I'd be happy to go over this with you. Once again, we just got through with 7-5 day 2. And it's been an adventure. I haven't had to yell at anybody for breaking pencils. I haven't had to yell at anybody for getting up in the middle of the class and throwing something away. And I haven't had to stop talking so that I can stare down a table to stop talking. I do miss it. Sounds crazy, but I do. Enjoy your rest of your day.